the subject is orchestration of telecom constellation networks.
So, difficult topic, I think, about communication. First, I would like to say that imagine a world today without communication. So life will be very difficult for us. Life will be difficult for military and so on. In fact, we are moving more and more in complexity in the telecommunication infrastructure because today there is a lot of interaction, combination between the different networks. So the terrestrial one, the classic one, is interact a lot with the mobile one, the 5G to 6G, and also with the satellite infrastructure. We can't think today having a network completely independent. It is impossible. And in parallel, we see that the complexity on space is growing up because we are facing today more and more constellation in parallel of geo satellite or MEO. And in parallel, there are some initiative in US with an operator like Link who plan to communicate directly on this iPhone from satellite. So it will be direct 5G, 6G on this iPhone. It's also the case in the military in the US because they want to replace the MEOS program also with a program, military program, telecommunication also with this capability. So then, why this introduction? Because it's at the core of these complexities. There is the network. There is then this orchestration of the network, and this orchestration of the network for sure is facing dynamic constraints. Is facing difficulties like obstacle like rain, and so on. So we need to be very flexible in this orchestration of network. And compared to what has been said this morning, that a human can be actor, I think in that domain, as we need to be quasi-real time, it's difficult to have a man at the control of this network. So then AI is an asset. So then we will talk about. I want to rapidly to introduce Marc. Marc Cartigny is 30 years experience in a group like first Alcatel and then Airbus. He was at the origin of the mobile IP network in the US, and also he implemented the software-defined network and the network with functional virtualization, which in fact replacement of the hardware by the virtual machine in the network. So Marc is one of the experts, and he is an executive expert today in Airbus, and he is managing, he manage the laboratory, the lab in telecommunication for Airbus in Issy-les-Moulineaux about AI and quantum technology. Nicolas is the chief architect of AI in Thales, Alenia Space. Nicolas has 2 decades of experience in artificial intelligence, data mining, and machine learning. He started his career in Amadeus, and he developed all the fast search speed of tickets for the passengers in Amadeus at a massive scale. So he developed all the AI to facilitate this search. And Djamal, he belonged to the Institut de Mines-Télécom, and Djamal is a professor and also is a director of the laboratory of multimedia and wireless technology in the Institut de Mines-Télécom. And Djamal worked in the NASA at the beginning, and he graduated from the US. So thank you to be with me. And so we will ask. We start maybe with you, Djamal. What is AI today, and what are the benefits? What are the technology? What's the purpose of AI today in the orchestration of network?
Okay, so basically when we look at satellite networks or non-terrestrial and terrestrial networks, they are very complex, and satellite networks are really dynamic. They change constantly. They are multi-orbit, There are also have multiple layers. You have the data plane, the control plane, the management plane. And we've seen that AI and machine learning can basically help when we have to deal with multi-objective optimization problems, when we have to basically dynamically adapt things, assess the environment, because machine learning and AI can also help us in predicting and identifying patterns, doing pattern recognition, and we see that they are useful in that sense, and they come and complement and strengthen the systems for better performance and better optimization on a general basis. They typically need to be combined, of course, with optimization, with genetic algorithms, with heuristic approaches, with rule-based techniques, with methods that are already in use in systems. But when we look at really what AI and machine learning can do, it is clear that there can be a real enhancement to the systems. But we are facing, however, in these complex systems, which are systems of systems, all these AI and machine learning algorithms will behave as agents. And I perceive them as multi-agent systems. And therefore, they should be treated as such. And even the intelligent methods or techniques coming from machine learning and coming from AI in general have to be combined, and also basically they should learn how to cooperate, and in fact coordinate their actions in order to make decisions. Of course, what's going to be essential is to basically use AI and machine learning techniques that are basically built for this cooperation and built for this coordination and this multi-agent operation, when we can perceive all the systems and the components where there is intelligence acting as multi-agent systems that are cooperative in some sense. And there are many methods that do so. And typically, I think the challenge is in exchanging the key information between the machine learning algorithms and changing the appropriate attention, the appropriate features, the appropriate gradients, and what have you, in order to basically get the global optimization as opposed to the exclusively the local ones. Now, if we look at the systems, they are basically so complex that any centralized or hybrid or semi-centralized system will typically have a hard time with quasi-real-time really optimization in the systems. And therefore, we need to distribute also this intelligence, and it needs to be cooperative. So I think that's probably what I'm going to retain as maybe what's really the most important in these constellations and these complex systems.
Thank you, Djamal.
Thank you.
Maybe to back to you, not to Marc, and taking
like
one word
interrouting.
about what you said about quasi-real time. Marc, can you extrapolate a little bit about what does it mean in a network and what are the methods, technology?
Can you hear me? Yeah. Okay. First of all, we have to understand in our AI lab initially, you mentioned, I built it to specialize on optimization and decision making for network. Initially, we did it for military SATCOM. So the characteristic of SATCOM are that the situation can potentially evolve very rapidly in terms of capacity due to weather conditions, due to interferences, jamming, and so on. And also, we have to take into account the characteristic of the customer, which is a military customer, of course, in terms of mission, in terms of operational context, in terms of priorities, and that can change also according to operational context typically. So even the application change. So everything is changing. So today, for SATCOM, we use now IP, Internet Protocol. That's to say it's very close to the internet. And when you have a problem with such technology, of course, the network is able to react dynamically and to answer to the problem in the network. But it does it according to static rule. For example, if I have a problem on link A, I decide to route the traffic on link B, which is not necessarily a good decision for satellite communication. Because imagine, nominally, link B has 100 megabits, but when you have to reroute, because of weather condition, the capacity is now 20 megabits. So by rerouting the traffic to link B, you amplify the problem. Okay? So what we want to do now is to not use static rules, but to calculate the rules to optimize the network usages. And to do that, we do it according to factors, for example, quality of experience, security. We can combine the factors, of course. And in order to do that, we had no choice. We did not go to AI because we wanted to make AI. We had no choice. We only had to do it for AI. And to make it even worse, we have to do it in real time or in quasi-real time. Maybe I can explain now what it means. What we have done is basically we work on the control plane. The control plane is a plane in the network which is in charge of taking care of problems or solving problems in real time. So we have decided to use a software-defined network solution, which is really SDN, which is really today the state-of-the-art solution for control plane, but SDN today is using static rules. So we wanted to replace it. So they have developed two algorithms to tell the SDN what to do, what to implement in the network. The first algorithm, remember, we have few seconds to react, typically 5 seconds to react. So the first algorithm is an exact algorithm. It guarantees the optimum, but not the time. Sometimes you can get an answer, sometimes you don't get an answer in 5 seconds. So we have to complement it with another algorithm, and this is a genetic algorithm, which are known to be very good at solving optimization problem. And here, you can guarantee the time, but you cannot guarantee you will get the optimum solution. So we let the 5 seconds running. After 5 seconds, if you have an answer from the exact algorithm, we take it and we ask the SDN controller to apply it in the network. If we don't, we take the answer from the genetic algorithm and we ask the SDN to apply it in the network. Now, in terms of results, because we measure it, we have developed it, and we measure it. It's not a formal verification. We went through thousands of tests, and what I can tell you now is, in average, the genetic algorithm gave solution in average which were at 93% of the optimum, which is quite good. The worst case we had was 84% of the optimum.
Thank you, Marc. Maybe Nicolas, maybe you want to add things on top of it, and in particular, what does it mean AI for more complex system? Typically, the link between the control system and the mission system, and more complex, I would say, with more like on the SCAF tomorrow. What does it mean?
Okay, sure, Eric. Thank you. Indeed, there is a trend in the space industry in general where there is more and more links between the mission center and the satellite control center, especially in the era of small, medium, or large constellation. The two needs to have common objective, joint objective to be optimized to guarantee an optimal performance for a constellation, for example. Historically, the two have been very separated and working more or less sequentially. The future is really about having shorter cycles. For example, if you think about a constellation, there is a need, for example, to have debris avoidance taking into consideration without impacting the telecommunication performance. Marc was mentioning interference, weather condition. This is the same idea. We need to take all that into account while controlling the satellite and guaranteeing as much as possible the performance of the telecom missions. And the good news is that we can use artificial intelligence to help solving those problems, which are very hard. mission planning, for example, is a NP-hard problem, very difficult to solve in a fast way. So we can use machine learning to speed up the decisions, and also taking into consideration external data sources such as the debris data or things like this that can be very helpful, and you will have a holistic optimization of the system by doing so. So this is what we can say about mission and control integration that are getting more and more integrated. Maybe a few words about the inter-satellite links.
Yes,
inter-satellite links, we have not talked about them that much so far. They are extremely, extremely important, and they are being developed very actively in different systems. Iris Square will have such inter-satellite links. This is the idea to have a laser links between, for example, the satellites of constellations. And this is interesting for several reasons. The first one is that machine learning can be used first to predict the moment where we will be able to point from one satellite to the other to optimize the routing performance and calculate the routing table more optimally by having a little bit of knowledge in advance before the actual contact. So this is very useful to optimize the routing. Another reason why it is interesting is that inter-satellite links will help to link in the future observation on telecommunication constellations. And this is very, very powerful, especially in the edge of edge computing. And we'll talk about it in a minute again. The observation satellite will send the data to Iris Square or maybe a geo satellite, and it will get back to the ground very, very quickly. This is absolutely essential for reactivity, especially in the military and the defense domain. The ODA loop is clearly shortened by doing so. You send the report and you send back the report thanks to a telecommunication satellite or a constellation to the ground so that the decision can be taken as fast as possible. So ISLs are extremely important.
Yeah, so I think we have not a lot, 5 minutes before question or? Including question. So then last question to you, what's future trend about AI and which other technology? We talk about quantum typically. Is it something can be linked or not? So maybe each of us.
Okay. So Djamal mentioned it. I think the future is really about collaborative agents, distributed collaborative agents. This is really the future. This is really for the future. So now speaking about quantum, what is funny is that the first time we have deployed our algorithm is for a quantum network, QKD network. We are currently building with Thales and Orange in a project called France QCI. This is a prototype, but we are testing our optimization software here. We have to tune it because the quantum resources are not the resources we have usually in a standard network.
Maybe I can add a few words about edge computing, which is a topic I am actively working on with our partner from IRT Saint-Exupéry in particular, where we are trying to have a highly powerful hardware platform to execute in a flexible way AI algorithm, especially for observation. So more and more, there has been an exponential growth of the computing power on board of the satellites. Since the past, let's say, 5 years, it has been absolutely incredible. When you look at the figure of the progress, it is really, really, really impressive. It opens many, many doors, and to control that properly, we need advanced software stacks that we did not develop so far that much, either in Airbus or Thales. We are on it together, by the way, and that's a very, very important topic. And flexibility and agility in terms of software on AI, of course, will be absolutely key for the future. Reactivity, operational superiority, again, this is a key for those aspects for me. Yeah.
Djamal, do you want to add something?
Yeah, maybe the other hidden challenge is basically to do compositional learning somehow. Because what you have to do later on, that I foresee in the more distant future, is that you have to combine the machine learning techniques as well. So you need to schedule them, you need to chain them, and they have to respond to the global objective of the global optimization. So I think this is also one of the challenges and things to look at. The other thing to keep in mind is that we have to develop also lightweight AI algorithms and machine learning algorithms that consume less, because we have limited budget, limited compute power, limited memory, limited disk space, what have you, on board as well.
Okay.
So I think that's also
Thank you,
a lot of
Djamal.
important
We'll stop here.
Thank
I
you.
want to conclude. So maybe there are some questions. Jean?
Yeah, there is a question of more we need for clarification. There is a question saying, could you give more detailed example of AI machine learning in routing of channels for telecommunications? I think it was after Nicolas saying something on that. Machine learning on the routing of channels. Concrete examples.
Maybe Marc, you
maybe
might
Marc.
do this one. I guess you
Well,
Okay.
in our maybe Djamal can answer because in our case we don't use learning.
We use machine learning to do basically load balancing and traffic engineering and routing in one shot. And basically we use multi-agent reinforcement learning, and we had to inject expert knowledge, results from exact algorithms as well in parallel. So it becomes a little bit more complex and more sophisticated, but turns out that it can be quite efficient. We've even gone further than that. There are methods and machine learning techniques that basically where the flows, the frames or the packets are the agents, the intelligent agents. So they act like cognitive packets and cognitive frames or cognitive flows, and then they end up doing things that really do make sense. Of course, this is exploratory. It seems very far-fetched, but it turns out that you learn a lot from there, and then you can build the appropriate algorithms in order to manage the dynamic aspects.
Yeah.
Now, you must use unsupervised learning rather than supervised learning. That's very important. If you do supervised learning, then you have to associate it with synthetic data set generations. So you may have to think about GANs to do that. And that maybe that leads us back to quantum
I think
technology.
we need to stop. Thank you very much. I think I know you are very competent. You have a lot of experience, knowledge, and so on. So it's not easy in so short time, to 5 minutes to do it. So thank you very much.
Thank you. Thank you.
Yeah, thank you very much. It was short, but the snapshots of information were definitely there. They are at your disposal for the break.